Okay, welcome everybody. Thanks for coming. Let me tell you the plan today. Today, as always, I will answer any questions you might have. That could be throughout the whole time, not a problem. And then, if you remember last week, chapter 5 at least, we talked about the um, continuous distributions. And um, I did the uniform distribution because that's the easiest, but it's actually not the most important. Okay, the most important distribution by far is the normal distribution. Okay, and we talked about the normal distribution actually in week one. It's so important, and that's kind of the kind of the baby way of saying it is bell curve, but we're going to be calling it normal distribution. There's actually a fancier way too called the Gaussian curve, named after the guy who kind of came up with it. Okay, so that's just a note. We're going to talk about the standard normal distribution. And then after that, we'll get into calculating probabilities and percentiles from the standard distribution. Then we'll talk about the general normal distribution. And then we'll calculate probabilities and percentiles from the general normal distribution. And then after that, I'll do a few applications. We'll do some of the applications that really you're not going to see the main point of the normal distribution until next week, because that's when we're going to have something called the central limit theorem, which just says we got to have the normal distribution or we can't do anything. Okay, it's kind of one of those things. So as a question of the project, so did I say you have to turn in the project on Sunday morning for you to give feedback? So if you remember the very last moment of possibility of getting feedback is the Sunday before the project is due. And notice if I go to, let's go to the syllabus. Then you'll see project is due by May 11th. Okay. So the Thursday before May 11th is May 8th, and that's 8 in the morning. But if you wait till the last minute, it might take me a couple days to read it because it's two big classes. So it could take a while. On the other hand, if you do it a few days before that, so that would be like a week from tomorrow, for example, then that would work. And then I'll be able to get to you much quicker. Okay, so that's kind of the timeline about the project. Does that make sense? So good question. It's an important one. Okay. Yeah, and that's for not turning in the project. That's for turning in your draft of the project. Okay. So your draft of the project, then I give you feedback, and then you kind of fix the problems. And then my recommendation is instead of May 11th, May 10th, is to be ready to turn it in by May 10th. And then you'll truly turn it in, if that makes sense. And I recommend a day before, and that way if something goes wrong, you have an extra day. Always a good idea. When you have a long time to do something, I recommend thinking about like the day before or a couple days before as like what you consider the deadline. Does that make sense? And that way, if something happens, then you can still have an extra day. So that's just a strong recommendation. And that's kind of a life skill. That's not a statistic skill, it's a life skill. Is if you have something important and you have a lot of days to do it, then try to get it finished, not the day that it's due, but a little before that. Okay, so hopefully that makes some sense. I want to mention something about this week, and that is chapter 6, which we're talking about. That's the normal distribution, is one of the easier chapters of the book. So it's kind of a lot less work than other weeks. But one of the main reasons I do that is one, we're in an even week. This is week 4. Why is it important that this is an even week? Yeah, even weeks mean exam. So make sure you do that exam. And you always want to do the chapter assignment before you do the exam because the exam literally grabs problems from the randomized chapter problems. So I recommend before you do the exam to finish and do well on the chapter 6 um, questions. Okay, and also the discussion post section. And don't wait till after Thursday to do discussion post because remember, it's due on Thursday to do your initial post. And if you do it on by Wednesday, then I look at it and I'll give you feedback if there's any issues for the original post. Okay, not for your response, but for your original post. So that's just a note. And then the other big thing, and we just mentioned it, is the project is coming and not that much longer from now. So this is the time to get moving on the project. And feel free to post any questions you have about the project on the Project One discussion board, and I'll answer them. So that's a good thing. You can also get help. Hector is here. So Hector can also help you out. Hector has lots of hours. Others people can too, but Hector is the main embedded tutor. And I could help if you log into my student hours. Any other questions? Any other questions? Okay, so if you remember in week 1, we talked about this kind of bell curve, which we are calling the normal curve. And there's something called the empirical rule, and that's actually going to be important, possibly important to your project. And this is what it says, is that if you have a normal distribution, then 68% probability of having a z-score between -1 and 1. And if you have the standard normal distribution, then that just means that there's a 68% probability of being between -1 and 1. There's a 95% probability of being between -2 and 2. And there's a 99.7% probability of being between -3 and 3. So we actually talked about this in week 1, but it's been a few weeks already. Of these 3, what's the most important of the 3? What do you think? Any guess? It's just a guess because we haven't used it yet, but I want to give you a heads up. Okay, 68% is a good guess, but no. No, it turns out the 95% is the most important, and you won't really understand why for another 2 weeks. And that has to do with something called a 95% confidence interval. So for now, just remember that. The others happen once in a while, but the 95% is really important. Okay. So any questions on how to read the empirical rule? Any questions on this? Okay. I just want to give you another heads up. This only works if you have a normal distribution. If you have data that, like from your project, how do you tell if you have a normal distribution or even an approximately normal distribution? In our class, at least. How could you tell? You collected your data, and let's say you surveyed 35 people. They all gave you numbers. How do you know? Okay, if it's bell-shaped, but how do you know if it's bell-shaped? All you have is a bunch of numbers. Right? 35 people just answered with the number, and you have 35 numbers. Yeah, you make a histogram. So that's one of the reasons why in Project One, you need to make a histogram because that will help you decide whether you have a normal distribution or not, or at least approximately normal. And if it looks approximately normal, then you can use this empirical rule. That's these percentages. If it doesn't look approximately normal, you cannot use the empirical rule. And then you have to go to like plan B, which isn't as good. And that's called Chevyshev's theorem. And that already happened a while back. But again, that's something you should be thinking about. I want to state that because that's part of Project One. If you don't, either use empirical rule or Chebyshev's and explain why, if you use Chebyshev's, why you had to, and if you use empirical, why you're allowed to, then that won't be good for your project. So make sure you do that when you look at the histogram. And in our class, we're just gonna look at it and say, yeah, it looks kind of bell-shaped. Okay, looks normal. Any questions on this picture? It's a very important picture. Have you seen this in the real world before? This shape? I don't mean on a piece of paper. But where do you see it in the real world? Comes up a lot. Okay, roller coasters. Okay, roller coasters. Kind of. I'm not going to get into the details. It's actually slightly different, but yeah, it looks kind of like it. Seismic waves can have a normal distribution. That's probably more sine or cosine. If you haven't had trig, don't worry about it. That's actually a little different. Let me tell you where you see it a lot, and you may not notice it. Hopefully, you've all been to the beach before, and you look at the shape of the sand piles. If you kind of look at those in 2 dimensions, those are normally distributed. You've all seen sand before, I hope, right? Okay, otherwise there's something wrong with your lives, right? If you've never seen sand. And that's kind of that kind of pile of sand looks like that. Next time you go out to the beach, take a look, you'll notice it, and it'll really look normal. Okay. It turns out it's a 3-dimensional normal because it's not just you know, a picture, it's a whole 3-dimensional thing, but it's got a 3-dimensional normal distribution. All right, so now let's do some example questions. So here's the first one. Suppose that Z follows a normal distribution, the standard normal distribution. And I just want to let you know, standard normal means the mean is 0 and the standard deviation is 1. So we're going to use the empirical rule, which is this picture, for the following. So the first one is find the probability that Z is between -1 and 1. And by the way, we did this with uniform distribution. I want to show you with normal distribution. We're using the letter Z. And then remember when we had the uniform, you wrote a tilde, and that means has the distribution. What do you think N stands for? The hope is it's obvious. It's not a trick question. Yeah, normal. Yeah, not number, normal. So it has a distribution that is a normal distribution. And the mean is 0. The first number is the mean for normal distributions. And the second number is the standard deviation. So we have mean 0 and standard deviation 1. So it's a little different than the uniform distribution. When we went from A to B, that was not mean and standard deviation. For normal distribution, you always write mean and standard deviation. Those turn out to be the important numbers. And if we have what's called a standard normal, that means the mean is 0 and the standard deviation is 1. That's like the easiest numbers you can have that make sense. So that's why. So what is the probability that Z is between -1 and 1? This should be really easy by just looking at the empirical rule, looking at the picture. What is that probability? Let's see if you can tell me. Yeah, it's better to write it as a decimal, though. You're writing percents, but turn it into decimal. Yeah, 0.68. Okay, so that is the probability because that's what the empirical rule says. Is that obvious? Okay, now let's go to part B. So part B is find the probability that Z is less than 3. So here's 3 over here. What is the probability that we're to the left? That's less than, is to the left of 3. That's a little bit harder. Okay, that's a bit harder, not impossible, but harder. So I don't expect you to just jump up and tell me the number immediately, whereas the 0.68, that was easy. If you agree, just look at it. The key on this one is we can say that we know between -3 and 3, but that's not enough because then we still have to the left of -3. Do you see how that works? But what I can do is say that that'll be the probability that we're between -3 and 3 plus the probability we're to the left of -3. Do you see that? Because the area of this very far left plus the area of this kind of wide middle is the area to the left of 3. So that is the probability that -3 is less than z is less than 3 plus the probability that z is less than -3. Any questions on how I broke that up into two pieces? Okay, so that is equal to, what's the probability that z is between -3 and 3? That's supposed to be pretty easy just from the picture. Yeah, 0.997. Because 99.7% chance. Turn it to a decimal, 0.997. Then I'm going to go plus. And now the key on this one. Now I want to say less than -3. That's this piece. And we know what it is between -3 and 3. So we have an outside piece. But one of the great things about the normal distribution is it has symmetry. So the outside left and the outside right, those have the same probabilities. They have the same area. Is that clear? Being less than -3 and being greater than 3 have the same probability. Okay, if you add those two up, then you get a probability. But if you take the whole thing and you remove the -3 to 3, that gives you the left and the right. Do you see how that little geometry works? So I'm going to go so what we're going to do now is we're going to say 1 minus, I'm going to put this parentheses, 0.997. That'll give us the left and the right. But if I want just the left, what do I have to do? If the left and the right are the same and I got the left and the right, how do I get just the left? Yeah, divide by 2. And that'll give me the probability. Okay, and then just for fun, I'm going to copy this. And I'll just make a new window. I'm going to paste. And it gives you 0.9985. Any questions? Have I lost anybody on that little bit of math? Okay, so if you randomly threw a dart at this, when you have a normal distribution, getting less than 3 is almost always going to happen. 99.85% chance. All right, now let's do the probability that z is between -1 and 2. So now we're from -1 to 2. So we can do something really similar. Could we know between -1 and 1? The 1 minus 0.997, yeah, that's the only one that's divided by 2. Because what we just did, because between -3 and 3, we grab that, and then we add the left-hand piece. So between -3 and 3, there's no division. We're just grabbing all that area. And the left-hand piece is half of the left plus the right. And that's what just happened. Okay, and we're going to do something similar in this part C. To find the probability that we're between -1 and 2, we're going to do something similar. We know between -1 and 1 what it is, and we add between 1 and 2. So now we can write this as the probability that -1 is less than z is less than 1 plus the probability that 1 is less than z is less than 2. Any questions on taking those two pieces, putting them together to get between -1 and 2? Any questions on that? Okay, that probability between -1 and 1, that's just 0.68. And then we're going to go plus. Now we're going to do something similar. Now we want this between -1 and 2. And what we can do is we can say that if we grab this between -1 and 2, and we grab between 1 and 2, and we grab between -2 and -1, put those together, and that's the same as taking between -2 to 2 and subtracting -1 to 1. But that would give you two pieces, so we got to divide by 2. So it's very similar to what we just did. So what we're going to do is now we're going to take the probability of being between -2 and 2, and that is 0.95. And let's put that in parentheses, actually. And then minus the probability of being between -1 and 1, and that's 0.68, and divide that by 2. Anybody lost on what I just did? Any questions? So it's cutting into pieces and realizing that the left and the right are the same. So if you have left and right together and you just want one of them, divide by 2. Any questions on this? Okay, now let's do another one. Okay. Find the value of z such that there is a 2.5% or 2.5% probability of being greater than this value z. So here we're going to say probability of, let's make this bigger. Probability of being greater than z. Okay. So we don't know what the value is, so let's give it, so we want the probability of being greater than z. Is equal to 0.025. Move the decimal over twice, and that's what you get. Any questions on that so far? So now what we do is we do a little trick, and it's something that we've been doing all along. Before, what we did is to find the probability, we divided by 2. But if we're given a probability and we want to find z, let's multiply by 2. Okay. So what is twice this probability? Okay. So in other words, greater than z, that is the right-hand side. Let's add the left-hand side. So the probability of being less than -z plus the probability of being greater than z is equal to 0.5, because we just double it, and double 0.025 is 0.05, lost a 0, sorry, is 0.05. Okay, that's the outside stuff. If we know the probability of being on the outside, how do you find the probability of being on the inside? If there's a 5% chance of being outside, what's the probability of being inside? So the inside is the probability that negative z is less than, let's call it x, is less than z. Lost the p. Yeah, 0.95. It's 1 minus 0.05, which is equal to 0.95. If there's a 5% chance of being outside, there's a 95% chance of being inside. And that's the good news, because that 0.95 is just screaming for us to understand it, because it's on the picture. So that means that we're here in this 95%, and that's between -2 and 2. If you have a 2% probability of being greater than this value, are you on the left or on the right? If 2.5% of all people are taller than you, are you tall or short? Yeah, you're on the right. You're tall. So that means z must be equal to 2 by the empirical rule. Any questions on this way of thinking? Kind of looking at pictures. Okay. Let's do another one. We're doing a bunch of these. The notation has you lost. Well, hopefully you know P stands for probability. Hopefully that should be obvious, right? P is probability. And then you say X is between negative Z and Z. So negative Z is less than X is less than Z. Does that help you a little bit? And you always put parentheses around that, the statement. So that's how the notation works. Hopefully it helps some. Okay, so what if you wanted to find the 16th percentile? So do you remember what it even means to be on the 16th percentile, at the 16th percentile? What's that definition of percentile? It's another thing that happened in the first week. Do you remember what percentile means? If it's 16th percentile, then it means the probability of being lower than it is 0.16. Does that make sense? Okay, so one thing, if you're 16th percentile, that means you're small, right? Whereas if you were 95th percentile, you're big. So we know that 16th percentile is on the low side. So we know it's got to be over here somewhere. It's going to be negative. Okay. Now we're going to do the same thing. There's a 16%, 0.16 is the area to the left. If you add that to the area to the right, on the other side, you get 0.16 plus 0.16, which is 0.32. That'll be the outside stuff. If the outside stuff is 0.32, the inside will be 1 minus 0.32, which is 0.68. Okay, so that means from the empirical rule, we're between -1 and 1, and the 16th percentile is the low side, so z is -1. Any questions on that argument? I did a little faster than the last one. It's similar, though. Okay. All right, let's suppose z is 1.3. Find its z-score. Who remembers a formula for z-score? We had a formula. Again, a lot of stuff coming from chapter 1 here. How do we get the formula for the z-score? Do you remember it? Sure. Do you remember z was x minus mu over sigma? Does that ring a bell? Hopefully that rings a bell. That was the z-score formula. So I can write z equals x minus mu over sigma. Okay. So we have our number, our value is 1.3. Mu is 0, and sigma is 1. 1.3 minus 0, I hope you don't need a calculator to subtract 0. 1.3 minus 0 is still 1.3. 1.3 divided by 1 is still 1.3. So the z-score for when z is 1.3 is 1.3. Any guess, what would the z-score be if our z value was, let's say, 2.6? The hint is it's very easy. It would be 2.6. It turns out the reason why we use the letter z for the standard normal distribution is it's its own z-score, always. Because if you subtract 0 and divide by 1, you're not doing anything. Any questions on any of these questions? Okay, so now let's get into not the standard normal distribution. Let's get into general normal distributions. So suppose that x follows a normal distribution with mean 114 and standard deviation 23. Okay. So the way we write this is we write x tilde n parenthesis 114 comma 23 end parenthesis. That's the notation. Okay. And by the way, I could ask you, for example, on the exam to write down the distribution. And this is writing down the distribution is this tilde stuff. So it's important you know how to do that. Is that clear? Okay. And the good news is tilde is easy to find on the keyboard. So you can type tilde. Okay. It's not one of the fancy letters or anything. It's right there next to the 1 and a shift. Okay. So now we want to find the probability that x is between 100 and 120. Okay, so I want to let you know if you had to do this by hand, you'd be crying. It is intense. Okay, so we're not going to do this by hand. How do you think we're going to do this? So it's going to be very different. We're not using the empirical rule here. Yeah, we're going to the calculator. So let's go to the calculator. And as I mentioned, I try to do things in the order at which we do things in class. So what calculator number, and I try to make it really obvious in terms of the way I've labeled it, which calculator number should we use? What calculator should we use? Hopefully you're all seeing the calculator. Yeah, number 8, normal probability. We have a normal distribution. Is that clear? So I'm going to click normal probability. And so here's what it says. First decide on less than, greater than, or between. Then fill in all the values except 1 and hit calculate. And the one that you don't fill in will be given to you. The last value. Okay, so now let's do what we need to do. We want the probability that 100 is less than x is less than 120. So is it first, second, or third? I hope you can hear me. I just showed the internet is unstable. I got that message. I hope we're okay. So which of these three is it? Less than, greater than, between? Okay, so again, we want the probability that 100 is less than x is less than 120. So do we want less than, greater than, or between? Yeah, sorry if my internet is having issues. Okay, not less than. Good try, but not less than. Look again what we have. 100 is less than x is less than 120. So look at the x. It's x that we're focusing on. Between. Because x is between 120, 100 and 120. Do you see how that works? X is not just less than a number. It's between these two numbers. So it is very important that you understand that. So I click on between. And now it gives me two boxes. If I clicked on less than, it would just give me one box. But with between, you need two boxes because there's two numbers. And the numbers are 100 and 120. So I click 100 and I click 120. Then it says, what does it mean? So the mean here is 114. It says, what is a standard deviation? Standard deviation is 23. And it says I'm supposed to leave something blank. I'm going to leave probability blank because that's what I don't know yet. And I hit calculate. And there it is. It'll even show you the normal curve. Do you see? The mean was 114. That's right in the center. And we have between 100 and 120. And it shades in the area. And there's our probability. Probably a lot more decimals than you'll ever want. Do you agree? So probability is 0.3315 if you want 4 decimal places. Any questions on how I use a calculator? Okay, part B is find the probability that x is greater than 200. Okay, so let's go back to start again. Do we want less than, greater than, or between? So again, less than, greater than, or between for this one. Yeah, this one's greater than. So I click on greater than. And in this case, it's greater than 200. So I put a 200. Any questions so far? And we have the same mean, same standard deviation that hasn't changed. We need to leave the probability blank. So I'm going to erase that number. And I'm going to hit calculate. Okay. And that is a very, very small probability. You'll see it's way, way out here. So almost nothing. The probability is 0.00000923. Any questions on what I just did? Okay. Now, how about the probability that x is less than 90? So it should be obvious. Do we want less than, greater than, or between? Yeah, we want less than, and then 90. And now I'm going to erase the probability. We have the same mean and standard deviation. That's not changing at all for this problem. And I hit calculate. And there you go. And here's the picture. Notice less than is to the left. And it's about 0.1484. Okay, rounded to 4 decimal places. Okay. The next one is a little complicated, especially in the typing, so I kind of wrote this one out. If we want the probability that x is greater than 105 given, remember that little line segment, that vertical line segment is given, x is less than 125, there was a formula. And that formula is when you have given, that means the numerator is a probability of both being true. So if you're both greater than 105 and less than 125, you could say x is between 105 and 125. And then divided by the probability of being less than 125. Any questions on using that formula that happened from chapter 3? And I'm not going to waste your time by showing you the calculator work of each of these, but this would be a between with a 105 and a 125, and you get 0.3360. This would be a less than with a 125, and that is a 0.6838. And I divided, I got 0.4914. Any questions at all on that calculation? Okay, so the next one is find the IQR. Remember, IQR stands for the interquartile range. Okay, and the formula was you take Q3 and you subtract Q1. Do you remember that? Do you remember what Q3 means? Yeah, it means that the probability of being less than that value is 0.75 or 75%. So here we know the probability is 0.75. We know the mean, we know the standard deviation, and it's the probability of being less than that value, but we don't know the value, so that's what we're going to leave blank now. Any questions on how I thought about Q3 and turned it and used the calculator to get it set? Okay, the probability is 0.75. That's what Q3 is all about. And it's the probability of being less than the value. The value is what we need to find out. And hit calculate, and there's my value, about 129.51 or so. Okay. So that's Q3, 129.51. And now I need to subtract Q1. What changes if I want to get Q1? So what do I have to change in my calculator if I want the first quartile? Yeah, I need to change the probability to 0.25. And again, I want this value of x, still less than some number, is now probability is 0.25. And I hit calculate. And that's about 98.49. So go minus 98.49. Any questions? Any questions on that subtraction? And then the easiest thing to do is I copy it. I'll put that right into the scientific calculator. And it's 31.02. Any questions on that? Okay. And then the next one is find the middle 84% of the data is between what two values? Okay, that one's going to take a little bit of thinking. So if the middle 84%, if the middle is 84%, how much is on the total of the outsides? Not 14. Yeah, 16. I'm going to write 0.16. So how much is on the left? If the total of the outsides, yeah, half of that. So left is 0.16 divided by 2. which is equal to 0.18, 0.08. So that tells me that the probability is 0.18, is 0.08. And I'm going to leave that blank, and that's the left. So now I'm going to click calculate. And so that tells me that the left-hand side is 81.68. Okay, now for the right-hand side, it's still going to be 0.08, but now we're on the right-hand side, so now we're, instead of less than, greater than some number. Same probability, and I click calculate, and I get 146.32 or so. So 146.32. And those, so it's between, so 84% of the data is between 81.68 and 146.32. Any questions on answering that? Okay, so the next one is, I just kind of did the whole thing because again, it's not hard. You just got to remember the formula. The z-score for the value of 117, z is x minus mu over sigma. X is 117. If you remember, mu was 114. So that's the 114 here. And sigma was 23. And I divide that by 23. And what I got is about 0.13. And that's the z-score. Notice, unlike the standard normal distribution, finding a z-score does change the number. You don't just get x again. So by the way, is 117 an outlier? What do you think? You say possibly? Yeah, absolutely not. Because outliers mean you got to be bigger than 2 or less than -2. Do you remember that? And 0.13 isn't even close to 2 or -2. It's really close to 0. So it's definitely not an outlier. Do you remember that? Okay. And that'll be important for your project, by the way. All right. Ready for a kind of a fun application? All right. So this is, I know there, at least from what I've seen in the chat boxes and stuff, a lot of you are into health. A lot of you are thinking about getting into medicine. Anyone think about getting into medicine here that's watching it today? I know that when I've been watching the discussion posts, there are a group of you that were. Okay, so this is kind of involved a little bit of medicine. Suppose that the time that you, or your wife if you're male, will give birth is normally distributed with mean 140 days and standard deviation 7 days. Okay, so I just want to let you know, this actually used to be a lot more accurate than it is now. So mean 140 days, you've probably heard this before. If you see when you see a kind of a pregnant woman, what's one of the big things you ask? Has something to do with this stuff? Yeah, when are you expecting, right? When's your due date? The mean is the due date, okay? If the mean, if you're expecting 140 days, does that mean you will be giving birth in 140 days? Definitely not. You might be, okay? Could you be giving birth in 300 days if you're expecting in 140? Definitely not. And that's because the standard deviation is 7. And that was true in the old days. I know that sounds weird because people are people. People 100 years ago are still people now, right? I don't know why it's not true anymore. I don't know. There's a reason. It's not math. C-sections. Okay, so if you only allow births to be natural, then 7 days actually is the standard deviation. That kind of cool? And it is a normal distribution. So this actually works as long as you don't get into the medicine stuff and pull a baby out. Okay, so that actually works. Okay, so now here comes the question. Okay, so the first thing I'm going to do before I even ask a question, I can immediately write x tilde n parenthesis 140 comma 7. That's when you see a word problem like this, it helps a lot to turn it into symbols immediately so you don't have to go back and read the whole sentence over and over again. Any questions so far? Okay, so now here comes the interesting question. I made this up. Okay, your boss has just scheduled you or your wife for a business trip out of the country. Okay, okay, you or your wife leave today and will return in 135 days. Find the probability your baby will be born out of the country. Any ideas how to find that? How to turn this into symbols. Whenever you have a word problem, you want to turn this into symbols. So if it's find the probability, we're going to use the capital P for probability and then a parenthesis. Okay, if the baby is born out of this country, okay, when was the baby born? Or when will the baby be born? What do you know about when the baby was born if the baby's born out of the country? How many days? Yeah, within 135 days is good, but even better is to say less than. X is less than 135. And I want to mention with the normal distribution, it's a continuous distribution. So if you're wondering whether it should be less than or should be less than or equal to, it actually makes no difference because that's exactly 135. So 134.99999 could happen. Do you see that? So you don't have to worry about issues with less than versus less than or equal to. They're the same meaning when you have a normal distribution. So now the good news is we know how to do this. Now you go to the calculator. So now we have the mean is 140, standard deviation 7. We want less than 135. So I'm going to click less than. I'm going to make that 135. Our mean was 140. Our standard deviation was 7. And we want the probability. So I leave that blank. Have I lost anyone? And we calculate it. And it's about a 23.75% chance, or a 0.2375. Okay, let's suppose you go into a country that doesn't have very good doctors and medicine and stuff. Would you be okay with that? Okay, I hope you wouldn't. Okay. Okay, and besides that, you probably want to, be together. If it's your baby together, right? Okay. So you probably wouldn't be okay. So here's the next. You decide that this is too risky. Okay. You don't want to lose your job either. So you decide that you're going to negotiate with your boss. And you want to make sure that there's no more than a 1% chance that the baby will be born outside the country. Okay? That might be good enough. If it's that small a chance, go for it. Does that make sense? Okay. What day should you ask to be the return date? Any questions on the question? So now we're going to say we want only a 1% chance that the baby will be born out of the country, but now we don't know which day. So now we can say the probability that X is less than, I'm going to put a question mark, less than we don't know, is equal to 1%. And remember, 1% is 0.01. It's important to know what you know and know what you don't know. And here, we know the probability. We don't know this value that it's less than. Any questions on that? Okay, so now we can go to the calculator. And we want the probability that we're less than we don't know. Same mean, same standard deviation. But now the probability, we want it to be 0.01. Did I go too fast, or are you following what just happened? You know, you want to tell me? Okay, and I hit calculate. And we have 123.7155. So if we want to make sure that it's less than 1%, no more, no, definitely not more than 1%, then you're negotiating with your boss and say, let's round down on this one. And how about 123 days? So return in 123 days. Any questions on that? Any questions? Kind of cool? Okay, and this is real stuff, because it's important to know what is the probability of something happening when you're talking about things like having a baby, okay, or all kinds of things, okay. So now let's get into the next question. Let me do this. Okay, so now let's imagine it's 138 days later, and the baby has not been born yet. Okay. Find the probability the baby will be born within the next 24 hours. Any questions on the question? Okay. So what we know is we know the baby hasn't been born. So now we have a given problem. So we want to find out the probability that it's in the next day, given that it hasn't been born yet, that it's at least 138 days later. So in terms of symbols now, we can say that's the probability that X is between 138 and 139, given X is greater than 138, because it hasn't been born yet. So we now know that it's more than 138 days. Within a day means between day 138 and 139, because after that will be more than a day. Any questions on how I came up with this formula? Any questions? Okay, then we had a formula, if you remember, for a given problem. That was the probability of A given B was the probability of A and B divided by the probability of B. But if it's greater, if it's between 138 and 139, and it's greater than 138, That's the same thing as just be between 138 and 139. Does that make sense? And then we divide by the probability of being greater than 138. So now we have two probabilities to find between 138 and 139. So I go to my calculator and I click between. And it's 138 and 139. And we find that probability. I hit calculate and I get this big number. I'll just copy most of it. So that's going to be 0.05565 and then divided by, now we want the probability that x is greater than 138. So now I click greater than. And we want 138. Erase the probability. And I click calculate. And I get this number, 0.61245 or so. Okay. No one cares about, 1,000th of a percent chance. So we got plenty of decimals here. Okay. And then if I copy that, put that into the scientific calculator, oops, I think I put too much in there. Let's try again. There we go. You get about 0.09. Or about a 9% chance that the baby's going to be born in the next day. Okay. And that's probably a big enough chance that you're not going to do anything crazy. You want to be not that far from the hospital. Any questions on this? Any questions? I got a trivia question kind of for you. This is really important to my brother. Any guess on what my brother does for a living? Any guess? Casino owner? No, that wouldn't be very important about having babies. Yeah, he delivers babies. Yeah, he's a baby deliverer. OBGYN, but his specialty is delivering babies. Kind of cool, isn't it? Yeah, so that's always fun. Yeah, so OBGYN deliveries. Yeah. I think he's mostly retired, but he's older than me. But it's so cool. Okay, let's do one more example. Okay, now let's suppose that you have an ice cream shop. Okay, always fun to think about. And let's suppose that the amount of ice cream that you sell in your shop is normally distributed with mean 950 ounces and standard deviation 120 ounces. Okay, and that's how your ice cream shop is. So we can say that X tilde N 950, 120. So let's find the probability that on a randomly selected day that you'll sell between 900 and 1,000 ounces of ice cream. And that's the same thing as P, parenthesis, 900 less than X, less than 1,000. Any questions on the question? Okay, again, we need a calculator for this. When you have all these numbers, what I usually like to do is just hit refresh, and that clears everything out. So which of the three? Less than, greater than, or between for what I want? Hopefully you've got it now that we've done some examples. So which is it? Less than, greater than, or between for what we want? Yeah, we want between. So I can click between, ask for the two numbers. The numbers are 900 and 1,000. The mean is 950. The standard deviation is 120. And I click calculate. And you get about 0.3231 rounded to 4 decimal places. Any questions on part A? Not too bad, right? Do you agree that this doesn't look like it's going to be that hard for the homework, for the assignment? Hopefully you agree. It's one of the easier days. Okay, now let's say in the morning you took stock of your supplies and you noticed you have 1,100 ounces of ice cream in your store. What is the probability that you're going to run out by the end of the day? Okay, what is that asking for? That's the probability of what? So what does it mean to run out? Less than 1,100. Okay, so if you end up having not very many customers who want it, so less than 1,100, you're not going to run out. Does that make sense? Greater than 100, yeah. Because if you have more 1,100, if you have more than 1,100, or customers that want more than 1,100 ounces of ice cream total, you're going to run out of ice cream. So we want the probability that X is greater than 1,100. So that's one of the hard parts, is reading the words. So you'd run out if your demand was more than what you have. Do you see that? So now we just go right to the calculator. I hit the greater than, and it's 1,100. And I want the probability, so that's blank. And I hit calculate. Okay, there's about a 10.56% chance, or 0.1056. Okay. By the way, if you own, an ice cream shop, and there's over a 10% chance of running out of ice cream in your ice cream shop, you really don't want that to happen, because all of a sudden people are going to be pissed off when they go to your ice cream shop and you got a sign saying no more ice cream when you're an ice cream shop. So here's now the next thing. Okay. You want to be, let's suppose instead of wanting to be, having a 10% chance, you don't want that. Let's suppose you want to be 99% certain you're not going to run out. How much do you need to have in stock at the beginning of the day? Do you see how important this kind of stuff is for business decisions? Okay, so what do we want to do now? It's kind of similar to part B. So let me do this probability, because again, running out means that you ended up having more need from customers than you got. So that is X is greater than we don't know. And that probability is, well, if there's a 99% certainty that you're not going to run out, so not running out means less than. And that would be 0.99. So the probability of not running out is 0.99. Not running out means that you didn't have too many customers. Does that make sense? So that means X is less than some number. And that probability is 0.99. We don't know that some number, which is fine because we go less than. If you don't know it, you leave it blank. And then the probability is 0.99. Same mean of standard deviation. That's not changing in this for this ice cream. Any questions on that? And calculate. And we have 1,229.1617. No one really cares about, a thousandth of an ounce. So how about 1,229.16? So keep 1,229.16 ounces in stock in the morning. Any questions on kind of how this normal distribution can work? Any questions? I do want to give you that big thumbs up that it's easier to watch me do it than to do it yourself. So make sure you practice and practice a bunch before the exam, because just to let you know, because now we're in week 4 of the exam. Let me tell you one more thing before we do that. And that is a secret word. The secret word is useful. And that's because the normal distribution is the most useful distribution in all of statistics. And we'll learn why next week. But you can trust me that it is. So useful is a secret word. Okay, so now that you know that, I want to mention a bunch of things. One is, again, the normal distribution is really important. You need to understand it because we're going to be using it pretty much just about the rest of this course. So this kind of stuff is really important. So please get help when you need it. Okay, second is, as I mentioned earlier, the week 4 exam is this week. Has to be done by Sunday. And here's how the week 4 exam works. Because the week 2 was just an exam on the 2 weeks you've covered. The week 4 covers all 4 all 4 weeks, but it has a stronger emphasis on week 3 and 4 than on 1 and 2. So you still are going to get some problems from 1 and 2, but you're going to get more problems from 3 and 4. And the written problems are from chapters 3 and 4. I want to give you a big heads up because I graded your project discussion board assignment from last week. And a lot of you did not use the verbiage, the words I told you had to use when interpreting the expected value. Okay, there's a good chance you're going to be asked to do that for the exam. And you have to use the words I told you to use when I went through the webinar last week. Okay, so pay attention to the webinars. All of you who are here live, you're doing that. But I'm guessing that some of you are just scrolling through to find that secret word, not even paying attention, and you're going to lose lots of points if you don't use the words I told you to use last week for expected value interpretation. Because there's a good chance you're going to be asked to interpret an expected value, and you have to use the words I told you were required. Okay, so again, watch the webinars. Don't just find the secret word. That's not enough. And take notes as you're watching them. So that's really important. So the again, all four chapters are fair game, but there's more on 3 and 4 than there is on 1 and 2. And the way it works is the first bunch of problems, it just randomly grabs the problems that you got from your homework. And you means y'all, everyone gets random problems. So there's a big collection of problems that it grabs from. Okay. And that gets sent to your chapter assignments. You get some of them, not all of them. And then when you get to the exam, you have the big collection and it'll grab one from the big collection, is the idea, or maybe two. And so if you want to practice for the exam, then you go back and redo the assignments until you get used to kind of a bunch of those problems. So that's kind of a suggestion for the exam. Okay, and then make sure you spend plenty of time this week on the project. Okay, that is really important. So at this point, hopefully you have your plan, and hopefully maybe you haven't yet, but you need to very soon, and that is get your data. Okay, and that is survey people. Okay, no children allowed. Don't survey children, but so survey people and don't just fake it. Literally ask people if there's a store or a class, make sure you ask the manager or the professor before you go in. They'll usually say yes. Also, what I have learned, if before you ask the person the question, introduce yourself and say, I'm taking a statistics class and we're required to do a survey of people for this project so that I could pass the class. And then almost everyone will answer your question. If you don't say that, then they'll think you're just some paid person and a lot of people aren't going to even listen to you. So that's just a suggestion to get people to answer your survey question. If you say that you're doing it for a project and you don't want to fail the class, then people feel sorry for you and then they'll almost always answer your question. Okay, does that make sense? My guess is you'd be the same. Is that someone said that you would answer a question, whereas if it was just some worker, that's making money, you may not answer the question. Okay. So that's about all I have to say for this webinar. I want to remind you, as always, after closing or turning off the recording, I'm always happy to answer questions. That could be of the project, about what we just did, or whatever it might be. So I'm going to stop the recording. Thanks for watching.